The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and thank you for attending our Lighting Design Using TracePro webinar. I'm Andrew Knight, Technical Sales Manager here at Lambda, and I have with me Dave Jacobson, who will be presenting. The subject of the webinar will be a demonstration of an LED luminaire design process using various tools in TracePro, including the Interactive Optimizer. We'll address all questions after the presentation. And with that, I am going to turn the meeting over to David. Thanks again for joining us.
Okay. Hey, thank you, Andy. As Andy mentioned, today's format will be a presentation, probably 20 to 30 minutes or so. We'll follow that up with a question and answer session. As we're going along, please feel free to submit your questions at any time using the question box on your GoToWebinar control panel. And again, we'll address all the questions at the end of the webinar. So the topic of today's webinar is using TracePro for LED lighting design applications. And what we've done, in the past year and a half or so, we've presented numerous webinars on different aspects of TracePro that are usable for the LED lighting design process. And the purpose of this webinar is to kind of tie that all together into one procedure that you may be able to use, one workflow that you can use for your LED lighting design. So what we're going to do today is we're going to start with a basic specification, and we're going to use that as a starting point for our design. Then we'll discuss how that specification can influence the choice of LEDs. Can you use a single LED, or you're going to use multiple or an array of LEDs? We'll use an LED data sheet to create a custom surface source property in TracePro. And we'll talk about setting up that initial model in TracePro and preparing the system for optimization. What do you need to do to get your system ready to be optimized? We'll show you how the Interactive Optimizer can be used to optimize the system. In this case, we're going to be looking at an LED lens. We'll also touch on using the scheme macro language inside the Interactive Optimizer to optimize the placement of the LEDs and/or luminaires. And then we'll validate the design using the analysis tools in TracePro. And finally, we'll wrap it up with a question and answer session. And just to reiterate, please feel free at any time during this presentation to submit any questions you have using the question panel in the GoToWebinar control box. Just a little note here before we get started. The current release of TracePro, just to update everybody, is TracePro 7.0.5. It was released a few weeks ago. And we encourage anybody that's current with their maintenance and support to please go to our website and download the latest release of TracePro. So let's get into our main topic here, using TracePro for LED lighting design. Here what I'm going to do is just to go through sort of a typical workflow that I might use if I was doing a lighting design project here. And we're going to start out with a specification or a design goal. You always need to know what's your goal, where are you going with this project. Then we'll calculate the source requirements. What area are we trying to illuminate? What values of illumination do we need, a luminance or a radiance? We can use those values then to pick a source and the number of sources that we might need. We can then model the source, or in some cases we can get a ray file directly from the manufacturer, so we don't have to model the source. We can take advantage of the fact that they've measured that in this case we'll stick with LEDs, but we'll assume the manufacturers measured their LED and made a ray file available on their website, and ray files can be inserted right into TracePro. Then what we'll do is the next step will be to set up the initial model of the optic, either a lens or a reflector or a combination of the two, in the Interactive Optimizer. In this case, as I mentioned, we're going to be looking at an LED lens. Then once we set up our initial model, we're going to export that to TracePro, and we're going to use that to set up the positions of the source and the target, and where's the optic going to be in relation to those. Then we'll go back to the Interactive Optimizer, and we'll set up our optimization goals and targets. Are we optimizing to a flux value, to an irradiance value, to an angular distribution or a profile, either an angular profile or an irradiance profile? And then we would run through the optimization of the optic. Then once the optimization is complete, we can send those results over to TracePro, and we can actually analyze the results. Did we meet our goal? Once we've decided, yes, we've met our goal, we can output the design. We can generate CAD files. We can generate IES files for transferring to another optical design program if need be. Then we could fabricate the prototype. And once you've fabricated a prototype, and hopefully using TracePro lets you cut down on the amount of prototypes you actually have to make. You can do all of your design work and your trial and error in software itself as opposed to actually making hardware. So once you fabricate a prototype, you can measure that and then verify, did it meet the design goals? And then if necessary, iterate back here. We can update the model and make any changes if need be. And then finally deliver the product to the customer. And that's where the payoff is, where you get paid for your design work. So as I mentioned, we're going to step through here we're going to use an LED luminaire example. And as we go through these slides, one thing I want to note is we're not necessarily going to dig into all the specifics of luminaire design. It's be a lot to cover in 20 minutes or so. Hopefully what I'm trying to do here is to give you an overview of how you can use TracePro in that design process and what the design process might look like and what the steps you can take. At the end of the webinar, we have an additional resources slide that we'll put up, and it'll talk about all the webinars that we've presented and the tutorials that we have available that will go into much more detail into all of these steps that we're going to cover today. So here's my basic specification I'm going to work with today. I've got a target size that's roughly 9 by 10 meters. I'm going to mount my luminaire at a height of about 8 meters. And I want to put, on average, of about 14 lux, or lumens per square meter, at that target surface. And I want this to be white light. So relatively basic specifications, really suited for this demonstration. I think typical specifications would be much more involved because you'd have limits on luminaire size, maybe on materials, cutoff angles for glare. So there'd be a lot more factors involved, but we're going to keep it simple for this demonstration. So from those specs, we can make some simple calculations. Our target area was 9 by 10 meters, so we've got an area of about 90 square meters. We can calculate the half angle based on our 9 meter width as being about 30 degrees. And if we calculate the total lumens for this, which our spec was 14 lumens per square meter, and we have 90 square meters, we're looking at, I'm just going to turn my pen on here so I can keep track. We're looking at a calculated total lumens of about 1,260 lumens. I used 2,000 as a design goal in this case. I wanted, put a little more light on the target than the minimum requirements. The minimum number of LEDs, well, sorry, I skipped a step here, but the individual LED I wound up choosing here has 60 lumens. And my next slide will mention what the LED is. And the minimum number of LEDs required to get this 2,000 lumens would be 34. I wound up using, in this design, 60. And as we get further on here in the slides, you'll see the arrangement that we came up with and the fact that it's nice to actually have a few extra in there as well. So we wanted a white LED. In this case, we picked, or for using for our example, an Osram Golden Dragon LUW W5SM. I downloaded the data sheet for this LED, and it lists a lumens range of 60 to 130. I tend to be a little pessimistic, so I work with the lower end of the specs. And if we use 60 of these, we get a total lumens available to put on our target of about 3,600 lumens. And if you remember from this previous slide, my goal is to get at least 2,000 lumens on the target. So we do have some room to work with here. And the next step in the process, we need to make this LED, make a surface source property for this LED so that we can use it in TracePro. I've cut and pasted, and this is actually using the surface source property generator utility. The folks here that are using TracePro 7.0 and newer know that we have the utilities available right in TracePro itself. So if you go to the utilities menu, you can open up the surface source property generator utility. And it's simply a matter of cutting and pasting the spectrum and the angular distribution into this utility and a few mouse clicks along the curve to trace out in this case here, the spectrum and then the angular distribution. In this case, I chose the rectangular plot of the angular distribution. We do have a couple tutorial videos available on our website that talk about specifically using this surface source property generator utility. The first one is an introductory tutorial that deals with just making a symmetrical LED, which in the case this is. Second one gets a little more advanced, and it deals with an asymmetric LED, where there's different polar distributions as you rotate around the LED. So say if the LED had a cylinder lens on it. So again, we made this property here, and this is what we'll use as our source in our modeling of the lens. One thing to note here is this LED has pretty much a Lambertian pattern for its angular distribution. And if we remember back here in our spec, we want to have about a 30-degree half angle. And in this case, we have a half angle probably closer to 60 degrees or so, and a total angle of about 80 degrees. So we can tell that we're going to need to put a lens in front of this in order to get our angle down to concentrate our light more on the target. So the next step, we've picked our source. We've got our starting point. Now we'd go into the interactive optimizer in TracePro. And once again, it's in the utilities menu. All people using TracePro 7.0 or newer, just go right to that utilities menu, open up the interactive optimizer. And what we've done here is we've sketched the initial lens design. This is our starting point. And what we want to do is we want to use this sketch and the point and click, or the point and drag ray tracing option, the interactive ray tracing option in the interactive optimizer to get a good starting point for our optimization. We don't want to just put a block in here and say optimize that to my target. It's just going to take a lot longer. So the closer you can get to this design with your initial try here in the optimizer, the faster and the better your optimization is going to be. We've also set up here variables. So these points here and here and then all along these curves, those are the variables we're going to use for our optimization. That's how much this optic is going to be able to move. And we can use this to control things such as the maximum or the minimum size of the lens. So this variable can move, this one here, can move out to this point. So we have a maximum width or a maximum radius of this optic. In this case, it's about a radius of 12.5 millimeters or so. So our optic would be no bigger than, say, an inch. So again, choose your variables. How much are you going to allow them to move in that space to change this shape? One thing I haven't touched on here as we've gone is that there's this an additional object here drawn in the optimizer. And what that's done is we're going to use a little bit of scheme macro code here, and we're going to subtract that shape from our lens. And the purpose of that is that's going to make the opening or the hole in the back of the lens where the LED itself actually sits. So the optimizer will send over these two shapes, and then it'll subtract this little rounded cone here from the lens, and makes a hollowed out area at the bottom of the lens where the LED will sit. And if we actually look at what the scheme code is for that, the macro, it's very simple. It's just subtract object 2 from object 1. The subtracting object is the second one listed, and the first object listed is what's going to stay. So one line of code, one command basically, will allow you to subtract that area out, and now you have a nice consistent space where your LED is going to sit inside of your lens. And you don't have to sit you don't have to worry about the LED actually interfering with the lens itself and having overlapping objects. So once we've generated that model, we can export that over to TracePro. And what we're going to do here now is we're actually going to set up the model. If we just export from the optimizer, we're going to have this lens here. So what I've gone in TracePro here is I've also inserted my LED model. In this case, it's a 3D model that I was able to download as well from the manufacturer's website. Insert that into the model, and we'll use that as our source. Show a little better view here from like a plan view. We can see in here we've set up our surface. We've set a surface up that we're going to use our surface source property. This is the property we generated a few slides ago using the surface source property generator utility. So this has our angular and our wavelength distribution on it. We have our lens here, the object in red, and we have our LED. So now we have a complete lens and LED package that we can use in our optimization. And the next step is to set up the target. This is where we're going to collect rays if we're looking for flux values, if we're looking for irradiance patterns. We need a surface to see that on. So we've set up a target here. In this case, the target is 9 meters wide and it's 40 meters long. I intentionally made the target larger in the length dimension than what my spec is. My spec is actually 10 meters, so it's roughly this portion here in the center of this target is where I'm looking for my light. My LED and lens is quite small, but it's actually sitting right there at the origin. I mentioned the distance from the LED to the target is 8 meters. That's our goal that was our mounting height from our specification. And one thing I've done here is I've named the surface of this target that's facing the LED with a name that I'm going to remember. In this case, it's named Look Here. You can pick any name you want for this, really. But in this case, we named it Look Here, and in another slide or two, you'll see why we use that, why we want to have a surface named that we can look at. Okay, and here's why we want to use that. So now that we have our model set up, really this is all the work we need to do in TracePro at this point. We have our LED, we have our lens, and we have our target. And the way we're going to do this optimization is we're actually going to optimize a single lens element at this one time. So we're going to optimize that for our angular distribution and for a flux value on this target. And then once we get our single element done, we'll make an array of those to complete the luminaire. So the next step is to actually set up our optimization goals. We've now gone back to the interactive optimizer, and we've gone here into the operands section. This is in the optimization window. In this case, we've set up 2 optimization targets, or operands. And the first is a flux value. So this is going to optimize to keep as much flux from that LED on the target as possible. And if you remember, when we picked the LED, we said it had a lumen output of 60 lumens. So we're going to use 60 lumens as our goal. You know, we're not going to get there, but that's the most it could possibly be. Now we need a surface we need to tell the optimizer where to look for those lumens, or where to look for that lumen value in the model. And that's where that surface that we named, look here, comes into play. So now when this optimizer is running, it'll send over the model to TracePro, it will run the ray trace, and then it'll look at that surface named look here and see how many lux are there, how many lumens are there. And then it'll use that as one of the optimization targets. Our next optimization target is a candela profile. So this is an angular distribution. And if you remember from our specification when we did our calculations, we said we wanted a 30-degree beam. So here we've set up our angular profile to be 30 degrees. And we can actually see over here our values have a, we're at about minus 27 plus 27 degrees. We're up very close to 100%. So it's really a flat top type distribution we're aiming for with a 30-degree angle. The other thing we can see here is we've equally weighted these operands. So it's going to look, when the optimization is running, it's going to equally weight both the flux target and the candela target. And you may want to, if one of those is more important than the other, you may want to adjust those weighting factors. If it's more important to have this nice angular distribution, you may give that a higher weight than the flux itself. A little bit more housekeeping to do before we actually start our optimization. We need to define our save path and our file prefixes. So this is where the data is going to be saved. Each iteration that this runs through is going to produce some files. And this is where this save path is where you tell it to save that data. And you can also give it a prefix so that each file starts with the same name or the same letter or number combination. And then they'll just be numbered sequentially from there. So this will be lens 1-1, lens 1-2, and on down through each iteration. And then the last thing to set up is our material property. In this case, it's plastic PMMA. People that have watched our webinars before on the optimizer know that the optimizer uses your material property catalog that's in TracePro. So any properties you have in TracePro are available for you to assign here in the optimizer. The little bit of scheme code that I mentioned as far as subtracting one object from the next is entered right here in this after scheme column. And just double-clicking on that brings up the little text editor window where you can actually type in the command. And the last step here is we defined our geometry as radially symmetric. So it's going to take this shape and revolve that around. So we're going to make a cylindrical lens. A circular lens, I should say, not cylindrical. And then once that's all set, just click Start. And we let the optimizer go and run. While the optimizer is running, it generates this optimization log. And a couple things you can look at here. In this case, we're looking at the trend chart. So here's our starting point, and here's our error function. And here's all the iterations it's gone through, and where it finally comes down to its solution there. So we're seeing a nice slope here. As it keeps running, the error function is getting lower and lower. This I set up, and I actually let this run overnight. One night, it ran through 700 iterations with the best result coming at iteration 698. The limiting factor here was the ray trace time. I was tracing 100,000 rays for the lens, and that took about 30 seconds to run on my computer. So the total time was about 6 hours to do this 700 iterations. Not too bad. Just let it run overnight. Come back, take a look at the results in the morning. Once you've reach the point where you've got an optimized design, you can update the model in TracePro. And all you do is, if we notice back here, it highlighted the best solution in red. So if you click on that row with a right click in the optimization log, it brings up a little box here. It says Update Model. You click Update Model, it'll send over that version of the model to TracePro. So it'll send you the updated, the optimized version of this lens that you can now use in TracePro to start, as we get here to our next steps, we're going to start to analyze the results and see where we got. A quick look here before we go on is before and after. I think you always have to show a before and after shot. So the black outline here is our initial lens, and the red is what we came up with after running through that approximately 6 hours of optimization. So it did make some changes to the design, flattened it out a little bit, and added a little more curvature here to the front. So now we've optimized a lens. We're going to start looking at the results in TracePro. We want to verify, did this meet our goals? And what do we have to go back and make more changes? So the first thing we're going to look at is a single LED centered on the target. And we look here, I'm showing the irradiance maps and the candela plots, both for ray tracing this single LED and lens combination. We're about 65% efficient and about 38 lumens on the target for this 60 lumen source. And we can see our target that we're really trying to illuminate is this area right here, and then letting it fall off on either side. We're obviously not meeting our 14 lux goal, since our max lux here we look at is only 0.7. Here's our angular distribution, and we can see 30 degrees is right here. So we have a nice beam that comes close to meeting our spec. We wanted a 30-degree beam with a fairly flat top on it. There is some extra light out here that at some point, if we further refine the design, we may want to see, can we capture that light and focus more of that into the center, make this a more efficient design. And to do that, we may have to make some compromises. We may want to go back and use a new starting condition that's different from the one that we used in this case, and see what happens. Okay, so we noticed we weren't meeting our lux value with a single LED, but we knew that right from the beginning that wasn't going to happen. So my first step is I made a linear array of these. And this is a single row, 12 LEDs, spacing is 50 millimeters apart, it's about 2 inches apart. And these are centered left to right, and they're running along the 9-meter side of the target. So if I go back a few slides here, this row of LEDs is running this way on the target. We see our angular distribution hasn't really changed, which I don't think we'd expect it to. We're still using the same lenses. We look here at our target now. We've filled in a little bit more. Our lux value is now up to, at least for the center, is up to about 8.5 lux. If we look at our max, it's 8.3. Our efficiency is the same, and our total flux is now up to 470. And you remember our goal for total flux was at least 2,000 lumens, and we wanted to keep at least 14 lux in this target area. So we've added more LEDs. In this case, we've now made a two-dimensional array, whereas I just took that single column of LEDs and spaced it linearly. Again, 50 millimeters spacing, and it's a flat plane of LEDs now. we look at our total flux, where we want to be. We're over 2,000 lumens. Problem is we're not really filling in these sides here as well as we'd like to yet. We've got a nice big spot of light. The irradiance distribution doesn't look that different than, a single LED. It's just more light superimposed on that point. So we can look at what do we need to do now. We know we now have enough light, so let's change the position of the LEDs around a little bit. See if we can improve this. And what we did is we curved the mounting plate for the LEDs. So these are now on a circular array. Spacing's still about the same. 12 LEDs in a column, 5 columns, total of 60 LEDs. And we've just rotated them so that the angle of rotation is 22.5 and 45 degrees on either side of the center. Well, now we start to see what we're looking for. Again, this is our target area. Much better fill in here. If we look over here, we're right around that 14. This is about our target area here. If we look at our profiles, the profiles are one going across this way, one going across this way. We're right in the target we were looking for. They're right around that 14 lux. We've lost a little bit of light because we're spreading it out more now. But we're still a little bit over our 2,000 lumens. And we see here our angular distribution across here is still roughly our 30 degrees. And now we're starting to see a wider angular distribution along the length of the target, which is the result of rotating those columns or rows of LEDs. So that's where we stopped with this design. We've gone through the steps, what we were hoping to do here, to show where things would happen and some of the steps you could use to actually go from a specification to a complete design. Once you're happy with the design, well, now you still have to get the results out, be able to send it to somebody so that they can manufacture it, or send some information along to other people. The first step would be to take the LED, the lens, and create a CAD model of it. So you can, from TracePro, you can natively save as SAT files, and if you have the STEP or IGES translators, you can also save STEP and IGES file formats. Generally, all three of those can be read by the majority of CAD programs out there. So this information you could then send out to your mechanical engineer, if you're using SolidWorks or Pro-E, and design the whole rest of the mechanical system and the optomechanical system around this lens. So again, just export your CAD models, SAT, STEP, IGES. You can also then send these models to the manufacturer so that they could make, in this case, a molded plastic optic of this lens. Another thing you may want to do is you may want to make an IES or an illumdat file for this luminaire. In this case, I'm doing this for the complete design. So this is the 60 LEDs in there with the 22 and 45 degree rotation on the outer rows. And an IES file or an illumdat file is a way you can save and exchange the photometric data from this system with other programs. Say something like Lightstar 4D from Oxytech, that you could then use to visualize this light in an architectural environment. You could model a parking lot or a street, put a light like this up at 8 meters and see what the light looks like down on the ground. So the IES files or the illumdat files, if you're typically illumdat files you see in European countries, IES files, US, and also used more so around the world. TracePro can output both IES and illumdat files. In this case, I'm just showing the output screen here for IES files. And the last thing I want to touch on is it's possible to use the interactive optimizer and scheme macro language to do such things as to optimize these angular positions. So right now what I did here is I went and we set these angles here more by a little bit of trial and error at being this angle here was 22.5 for each of these. So they're both the same. But it's possible using the interactive optimizer to define a variable for this angle and let the optimizer use this, send these lenses over to TracePro and do this optimization and find out what is the best angular distribution for this. And it involves, what you would do is once your design is fixed, you'd actually remove all the variables from your design, and then you'd assign a new variable that in this case could be called angle, and then use that angle, that variable angle, with part of the code to change this and then look at the results. We'll have the optimizer look at these results, say on an irradiance map, to see what's happening. The September of 2010 webinar covers this in much more detail than what we can do right here now, but it is a capability that you can add, and I think we may look at a future webinar to address this more in detail, because I think it probably deserves a webinar of its own, just getting into this level of detail. I mentioned I wanted to, let everybody know some of the additional resources, and these are things that are covering a lot of the topics we covered here in more detail. So the February and March of 2010 webinars deal with the interactive optimizer, as does the September 2010. The September 2010 is a much more in-depth look at some of the features and some of the more advanced things you can do with the optimizer. What I would suggest to people to do if they're interested in this is watch these two before looking at the September of 2010 one. In July of 2010, we did a webinar on modeling light sources in TracePro. So we could, it talks about the differences of when should use a grid source, a file source, a surface source property, the advantages and disadvantages of each one. The October webinar from last year was focused solely on lighting files in TracePro, so IES and LUMDAT files, making them and using them, importing and exporting them in TracePro, as well as touching on what really is an IES file and why would you want to use it. And then lastly, the February webinar from this year was focused on the design and design verification and analysis tools in TracePro. So looking at the irradiance maps, the candela plots, luminance and radiance maps, all the different tools you can use in TracePro to analyze your designs. And then lastly, we have a tutorial available on making an LED surface source property. So all of these are available on our website. For the webinars, it's the webinars portion of the website, and for the videos, it's at the videos, and there's a banner menu right across the top of our website, our homepage, that you can use to go to these different sections. As we wrap up here, we'd like to say thanks to the AMOC at the Hong Kong Polytechnics University for providing us with the initial design for this luminaire. They provided that initial lens design that we used. So we'd like to, again, thank you to those folks. I'd also like to mention now, here's where we're wrapping this up, that at this point we do have a couple special offers available for TracePro. And I think, Andy, if you come back online, if you want to touch on any of these.
Sure. Hopefully everybody got the emailing that we sent out that basically there's two promotions we're offering right now, $1,000 off the TracePro Bridge for SolidWorks, and the special offer number 2 is a 50% saving on back maintenance and support. So if you have a license that's been out of support for more than a year or two, you can really save some money getting it back up in current, so that you can download the latest version of TracePro and of course call on support everything again. So yeah, that's something we wanted to touch on, and then I guess maybe we should address some of these questions, David.
Sure.
I have one here that's when a Lambertian LED has a spread of 120 degrees, does the spread correspond to the full width half max?
You'd have to look at what, the way they have it set up. Yeah, it would probably be typically about a full width half max. But I mean, Lambertian means it's going to be the outputs falling off is the cosine of the angle as you go off of the normal. So you could plot that out and see where full width half max usually means the 50% points. So that's probably somewhere in that ballpark. Yeah, most LEDs are probably 120 to 160 degrees total output angle. Roughly plus or minus 80 degrees for the total output.
Okay. I have another question, and that is, I assume that it is best to use ray data from the manufacturer instead of constructing a source model using the source property generator.
Maybe. This is one I would definitely say go back, take a look at the July 2010 webinar. Covered a lot of that in detail. There's pluses and minuses to both. Using the ray file, yes, you're getting measured data from the manufacturer. It takes into account all of the body of the LED and basically all of the mechanical structure of it. The downside to ray files is they're typically monochromatic. So you're going to be looking at a single wavelength. If you use a surface source property, you can add in all the wavelengths. So you can get polychromatic light. You can look at color rendering, CCTs, correlated color temperatures, and see what the effect actually have there. So that it's a mix, and it depends on what you're doing. In some cases, you may really even want to make an actual 3D model of the LED right down to all the appropriate material and surface properties, especially if you're close coupling an optic to it, and you might have effects of the light coming back out of the optic interfering with the LED itself. So there's advantages and disadvantages to both. But a lot of times, if you can get a ray file, it's a good starting point. And a lot of people do use them. Sometimes the limitation is getting a ray file because they're not available for everything. But whereas a surface source property you can make if you have the information from the data sheet.
Okay. I have a question here. Does LC version have optimization function? And that is easily answered. LC does not, because it does not support scheme. So only TracePro Standard and TracePro Expert have the optimization utility built into them. And the next question is a little complex. From a CAD point of view, there is a limitation. We can assume that we can download with an SAT file. From that, I assume you can transfer to another CAD package. But this is a dumb file. We cannot get at the math data easily. This is needed to put fillets on the system or to actually construct an equation for adjusting. We can use a spline, I think I should paraphrase, as an approximation, but it is an approximation. Any thoughts?
Well, I mean, there might be some limitations to what the actual file is. The optimizer is typically going to generate spline surfaces. So I'm not really fully up on how all the CAD formats handle all that, but if there's limitations to SAT, there's also options for STEP and IGES. I don't know if those have the same limitations or not. We'd certainly maybe have to take a look at that, and we could possibly get back to them on that question as well.
Okay. Let's see. How do we treat an RGB multicolor LED in TracePro?
This is a case where I would doing things using the surface source property generator, the surface source property utility, and modeling surface source properties would be the way to go in TracePro, because you can model the individual wavelengths of the individual spectral distributions of each LED. So if you're doing, RGB and you have, discrete LEDs for each of those three colors, each of those LEDs in the model could have its own spectral or its own spectrum. So then you could see color mixing at the surface. One of the options in the interactive optimizer is actually for the optimize to CIE values. So you could make an optic to do color mixing and optimize to a specific color coordinates. But yeah, I would look at a surface source property generator utility and surface source properties for modeling RGB type stuff.
Okay. What product do you have to make the luminaire design? I would say any of the versions or editions of TracePro can be used to design a luminaire, and obviously standard and expert would have the ability to actually do some automated optimization, but LC is perfectly capable of designing luminaires as well. And then question after that is, if I have an LED supplier spec file which is specifying the light source in millicandelas or microcandelas, not sure what that is, and the angle distribution, how can TracePro help to convert this to the source file, and how to verify this?
Okay, well, MCD is millicandelas. So they're giving you the angular distribution and the output of that angular distribution, the MCD. And the way I would do that is I would use the surface, if it's in a graph, I would use the surface source property generator utility. Again, go and look at the tutorial on the website for making an LED surface property. And you can trace in that angular distribution. And then what I would do is I would apply that to a surface in TracePro, run the ray trace on it, say run 1,000,000 rays, 100,000 rays, and look at a candela plot. And a candela plot shows you the angular distribution in this case, if you're in photometric units, the values will be in candelas. And then you can adjust the scale of that. When you're applying a surface source property in TracePro, there's an option for scale. And you can scale the value up and down to meet that MCD value that you have. I think real quick, maybe if I can jump back to TracePro here. If I look at this property here, this is my surface source property that I generated for this, in this case, this Golden Dragon LED, this LUW5SM. And here's the scale box I was talking about. And you can use that scale to update to do the millicandelas. So for an example, I'm going to turn the lens off here and run a quick ray trace. Only take a couple seconds. Okay. If I go to my candela plots, in this case I'm looking at a rectangular distribution, but there's also a polar option. And here's my output in candela. So in this case, this has an output of about 20 candelas or 20,000 MCD. So you could adjust this. If I change this scale factor here to, say, half of that value, I'd have half the MCD. So you can play around with that scale factor and adjust it to get the output that you needed. Now, in this case, I'd scale the output of this LED to give me the 60 lumens that I needed for this design.
Okay. And it looks like we don't have any other questions at the moment.
Okay.
I will put out one more call for questions, and if we don't get any in the next minute or so, I will probably be a good time to stop, since we went over time just a little bit.
Yep. Well, and again, too, if anybody is looking for some additional information, we can be contacted here, Lambda Research Corporation in Littleton, 978-486-0766, And please, be sure to visit our website, www.lambdares.com. We will be putting an archive version of this webinar up there on the website probably within the next day or so. So if you go to that webinars page, you'll be able to download and rewatch this webinar. Or if there's somebody that you know that was unable to attend today, please feel free to forward this information along to them. I see we did have one question pop in here on luminance analysis. Do we have a webinar on luminance analysis? We don't have one specifically on luminance analysis, but it is covered, I believe, in the February of 2011 webinar on the analysis tools in TracePro on luminance and radiance. There's also a tutorial on our website in the tutorial section on the luminance map. It's called the luminance map example. So you can download that as well. And,
okay. Well,
again, I just encourage everybody, take a look at the resources here, our webinars and our videos, just to get a little more in depth on what we covered today.
all right, everybody. Well, David and I thank you again for attending the webinar, and we certainly hope you will join us next time, which will be in approximately a month or so. So in the meantime, have a great day, and thanks again for joining us.
Thank you very much.